from the AIP Center for History of Physics. We have Connor Day and Brean Prefontaine.
All right, hi everyone, my name is Connor Day. I just graduated with my bachelor's in physics from Agnes Scott College located in Atlanta, Georgia.
And I am Brean Prefontaine. I am currently at Drexel University and pursuing a physics degree. I will be going into my junior year.
So we are the two AIP Center for History of Physics interns, and we worked on a project focusing on improving the visibility of women and African Americans in the physical sciences. And this project was created back in 2013 with the first intern team. Our goal was to produce a large series of educational materials covering the history of women and underrepresented minorities in physics. The project brings interns as well as graduate students in the history of science here to AIP to work on these materials and resources. The 2013 team focused mainly on women, creating lesson plans and other resources on a diverse group of women in physics who have done a lot of work in the field. The 2014 team focused on African Americans. But this year, we came in and focused less on creating materials and more on updating what these two previous teams had already done. Our main focus was to update a lot of the resources, as well as to make them a lot more accessible to the teachers that would be using them, as well as making them more active and engaging for the students that would be receiving the materials. So, to prove a little point of ours, we're going to borrow a technique that was presented to us by Rachel Ivey, who is here today, at the history workshop, teachers workshop that the History Center held last week. We did a quick Google search of the word physicist, and as you can see, a lot of the physicists who come up are Caucasian men who are exposed to young physicists at an early age. One of them is, of course, Einstein. We have Newton, Stephen Hawking. We have a couple of minorities in physics, one of which is up here, Neil deGrasse Tyson. His face comes up a lot in physics. However, the issue that we're here to solve is not a whole lot of other underrepresented minorities are exposed to young physicists as they are exposed to the subject itself. And it makes them harder to find role models and other people that they can personally identify with in the field, and it kind of deters them from pursuing it in their career fields once they graduate from high school. So that is the main motivation behind our work here. So our project is to create educational materials that are posted on the History Center's website. This is just a screenshot of the website as it is currently. As you can see in the middle here, we have a link to our teaching guides and a lot of the other resources that the center has up on the website. The resources include lesson plans, as I've said, research guides, puzzles and games, as well as a few other links to materials published by NASA, NIST, and other AIP-affiliated organizations. The project was initially created to target high school physics classrooms. However, one of our main goals this year was to expand the materials to make them more, or easier to integrate into not necessarily physics classrooms, but history, English, even drama. We have a few role-playing activities that we've integrated, as well as to modify the materials in a way that they can be applied at younger ages, even down to the elementary school level. The elementary school kids love crosswords and coloring pages and all that kind of stuff. So I will pass the mic over to Brean to speak a little bit more about the details of the resources.
So as Connor mentioned, this is the website where all of the lesson plans are housed. I just quickly wanted to go over what is on the website. So, before Connor and I got here, there were 20 lesson plans pertaining to women and 19 pertaining to African Americans, and this is great. But like Connor said, we are here to improve, so that's exactly what we did. So this is a screenshot. I don't expect you to read it. It's very hard to read, it's small. But this is what a lesson plan looked like before we got here. So this is a lesson plan dealing with 4 women who did research that could have led to a possible Nobel Prize, but they did not receive a Nobel Prize. So this lesson plan asked students to read about these women, do some research, look at some case studies, and then present their case to the class, and the class has to vote on what they think should have happened. So did the committee make the right choice? Maybe these women were left out, what was going on? So it's a pretty interactive lesson, but there's a lot of room for improvement. So, how do we tackle this project? We already had the lesson plans, we were trying to make them better. So one thing that we did when we started off was a lot of reading. And this is where the library came in, it was great. We looked at sources that past interns had used, we looked at news sources, we did some fact checking, and these resources came in to play in many different areas. It allowed us to rewrite some lesson plans in a different way, it allowed us to highlight some different things, so it was really great. We also did some work in the archives. So each intern hosted a tour at their site over the summer as part of the SPS program. We decided to take this time and play around in the archives. This was really great. We found some materials that related to women in physics and SPS and different things that were really interesting and had to do with history. So we pulled those out. We put on a little exhibit during the tour. I thought it was a great hit. It was also a great success. So those are some pictures of our exhibit and us setting up the exhibit. So getting into changing the lesson plans a little bit. Some of the lesson plans, the instructions were unclear or they just really needed help. So we decided that the 5A model might be a really great way to go about this. For those of you that are not familiar with the 5A model, it encompasses all of these things. So we have an engagement portion, explore, explain, elaborate, and evaluate. And basically this means that while the teacher is doing all 4 of the E's on the outside, they can also evaluate the student at all times. So even if teachers don't use the 5A model, they probably are anyway, because it's pretty intuitive. So we use the 5A model in our lesson plan. This is the same lesson plan. We reformatted it so it was easier for teachers to use. And I have a bigger version of it, although slightly blurry. As you can see, we have the grade level for the lesson plan. So this lesson plan, we actually rewrote it to include 2 lesson plans. So we have a middle school version and a high school and beyond version. So that's why it says 9+, right up there. And then we have subjects. So this lesson plan we suggest would be good for a history or physics class. We also have how long it takes to complete the lesson plan. That's a really big gap in time because the lesson plan is really flexible. So teachers can make part of it homework or extend it over 2 periods, whatever they think is best for their class. Prep time, materials, all the materials are included online with the lesson plan and some objectives. So going back, you also can't read this, but you can see the layout and the chart over there. So that is the first E in the 5A model. It's the engagement portion of this lesson. And so on the top, it gives the teacher a little overview of what's in that part of the lesson. On the left-hand side, it gives what the teacher is doing during that part. And then on the right-hand side, it gives what the students are doing during that part. So it's a pretty great way of structuring instructions. This was also a case study that we rewrote for this lesson plan. It was in bullet points, so we made it a little bit more interesting. We included more information that was based on all of our readings. It's just a great improvement. And so not to focus too much on women, we have an African American lesson plan. This is African Americans in astronomy and astrophysics. I really liked this lesson plan. I rewrote this one as well to be the 5A model. This lesson plan was great because it talks about an earlier physicist and a later physicist, so students can see the time difference. So I also highlighted this lesson plan because it comes with a lot of resources. We have a worksheet, an oral history, which the History Center does a lot of oral history, so we try to utilize those in our lesson plans. We also have a primary source document. And these are great for students because they can look at these resources like an oral history or a primary source, and they can really understand, or try to understand a little bit about the historical context. And most importantly, to some people, like teachers, we have standards. So no one really likes standards, but they're necessary. And well, maybe some people do, I don't know. So no one really likes looking at standards in class, but that takes time. So we've done that. So we included standards in all of our lessons, and teachers love us for that, so it's really great. So we are working on having more standards in all of the lesson plans and really organizing the lesson plans in such a way that teachers can easily look for a standard they need to fulfill and then pick up a lesson plan. It just makes the teachers' life easier. It sounds like we worked a lot on lesson plans, and we did. We also did some other things. Educational games are always fun. The students like them, so we made up 3 games. And all these games will be available online in PDF format, so the teachers don't have to go out and buy it. They just print it off, which is great, because teachers like things that they can print. So the first game is Scientists of Catan. This game is based off of Settlers of Catan, so if you played that game, this is pretty similar. Except for resources, we have grad students, or time, or money, or ideas. So, instead of selling sheep, you could sell grad students. So we have a manual, a full manual, and it tells you how to make the game. The PDF will include the tiles and also all the cards, so you can just print all those out. And it tells you, has recommendations for game pieces that you can use to make the game. It's pretty simple to set up. It's also great for, maybe an SPS chapter in a physics department. College kids like games too, so that's fun. We also have Heads Up. So this is a card game. I don't know if people have probably played this. It's pretty popular. You hold a card up to your head. Other people give you clues. You have to guess who you are. So we made it harder. We made it physicist. Why not? So we color-coded these cards. So we made enough cards in each color that we can have separate decks. So we have a women's deck, which is in yellow, African Americans, which is in blue, and famous people, which is in orange. So that's kind of like, if you know anything, you should be able to guess these people. So these are really great. So all of the women, or most of the women African American, come from our lesson plans. So if the teachers are using our lesson plans, then the students will probably know something about these people, and then they'll be able to give clues and guess who they are. And the last game, I'm going to let Connor explain, because that was her project.
Thank you. So Brean worked on Heads Up. Our graduate student Joanna, who isn't here today, worked on Catan. But mine was an extension of a game that was created last year by the intern team called Physics History. It was based on the timeline game Chronology, if anyone has played that. I'd never played it until I got here. But basically the goal is to create a timeline of 10 cards, such as these. You start out with one single card that you can see in front of you, has an event in physics history on it and the date that that event occurred. Then another player will read an event to you from a different card, but not reveal the date. And you have to guess whether that event that was read to you occurred before the event that is sitting in front of you or after it. If you get it right, you get the card and you get to add it to your timeline. If not, play continues around the table until somebody gets it right, and then they get to that card. The fun in it is that as people get things wrong, you can learn from their mistakes and cut out, this chunk of time. If you know that something occurred before, or didn't occur before 1791, that's, a relatively large chunk of time. So my cards are also color-coded. The yellow ones are African Americans, the green ones are general physicists, women, and the blue cards are women, and there are also a few cards that are blue and yellow, African American women in physics. So it's nice because you can play just with certain decks, and I forgot to mention that we put a few of the cards on the tables if you want to go check them out. We can play later once the presentations are over. And it's really nice because most of the events that are included in the game are events that are directly related to the content of our lesson plans. We got to try these games out at a history teachers workshop that the History Center hosted last week. We invited 9 high school teachers here to AIP to give us feedback on the lesson plans and resources, and just give us more ideas to improve our work. They were a lot of fun to work with, as I'm sure many of you know. High school teachers are awesome. And as you can see, most everybody was having a good time. So one of the major ideas that came out of this workshop was an organizational system that we can use to on the website to help teachers navigate all of the resources that we have available. NASA has a really good educator's guide on rocketry that uses a similar system that we're going to adapt in the future. In this matrix here, you can see that these are all titles of different activities and lesson plans, et cetera, that NASA has in their guides. And then on the top, there are different standards and subjects that are included in the lesson plans that can make them a little bit easier to integrate into the curriculum. We can also adapt this type of organizational process to grade levels for the lesson plans, as well as actual NGSS or Common Core standards. Another idea that came up is an organizational system that we can use that is keyword-based on our website. This type of thing is already used in our segregated visual archives that the History Center has up, as well as our oral histories that are published on the website. As you can see over here, there's a keyword search, as well as you can filter the pictures and oral histories by keyword. So our plan is to have a similar system integrated within the next few months that is related to our lesson plans. So some other future ideas that aren't published yet, but the team will be working on in the future include the queer community in physics. There are a lot of great LGBT activists out there that are working in physics, and one of the examples of this is the Out in STEM program. It is a program that's been around for about 5 or 6 years. They held conferences at universities all across the nation to promote the professional queer community in physics and other STEM fields, of course. And they are really booming. They're starting to work with APS a little bit, I think, and we need to get the word out there for that. Over here is Gabriela Gonzalez. She's an immigrant physicist from Argentina who is a main collaborator on the LIGAR project. She works at LSU. I got to meet her at the last year's conference for undergraduate women in physics. She was the keynote speaker for the conference. She was a really great lady, and I think her story is really important to be told. As well as physicists with disabilities, Einstein is one of the spearhead, or it's not necessarily the word I was looking for, but the main physicist that you would think of who has a disability. He suffered from dyslexia. However, there are a lot of other physicists that we can tell their stories to create more role models for students at a younger age who may suffer from similar disabilities. So in closing, we have a lot of people to thank. First and foremost, our mentor Greg for being a general awesome person and being very patient with us over the summer. Our graduate student team member, Joanna Behrman. Joe, Melanie, Steph, and all of the staff at the Niels Bohr Library and Archives. You guys have really helped us navigate through all these resources that are available, and Melanie did a great job helping us out with the archives exhibit that we spoke about earlier, as well as the Statistical Research Center here at AIP for letting us invade your space for the summer, as well as SPS and all the past interns for their contributions to the project. Thank you.
So, can you get the word out to history groups, groups that aren't sort of our normal interaction community here at AIP about these resources?
I think the library and archive staff here have a lot of good connections with that community, if I'm not wrong. I'm sure Greg does. So hopefully, and I've made a lot of connections as well, just through the people I've talked to here. So as we can get more and more people talking about them and more people using these resources in the classroom, hopefully word of mouth will help them spread as much as possible. Do you have anything to say?
I was just curious, you said you had graduate students as a sheep, what were the other cards? The other,
The other cards?
On Catan.
Oh, they're upstairs. We can bring them down.
okay, I'd love to see it.
Okay.
Just what are the resources?
The resources.
Oh, okay.
We had time, ideas, money, and publications. So all things that you deal with as a scientist.
The currency of science, very good.
I think time.
Yeah, when we played, so we played this game with the teachers that came, and it was really great to play it, because people had maybe a lot of ideas, but no time. Or maybe they had a lot of money, but no ideas. So it was like you see these things that mimic real life, and it's pretty cool. But I definitely liked it when they started selling grad students.
Where would you like to see these games played most? Like what environment?
So all of these games were created to be included in the high school environment or middle school, or I wouldn't really say elementary school, but middle school, high school, and beyond. That's sort of our target for the lesson plans. So I think anywhere that the lesson plans are being used, the games could be used as well.
I think the Catan game would be the most fun for college students and above, even the teachers, just because that age group understands the world of the way science and publications work. However, I know a lot of high school students are interested in the actual Settlers of Catan game, so maybe it would be applicable. I'd be interested to see that, but I agree with Brean about the card games.